Welcome back to Corbin AI, where I'm showing you daily how to start leveraging artificial intelligence in your personal and your business life. And you click on today's video as we're going to do a deep dive into OpenAI's documentation and more specifically in the context of when you code with it. Now, that being said, if you're using the Zapier automations and make automations, this kind of insight can still be very useful in the context of building out through no code platforms. But for this specific video, we're going to be discussing how to prompt engineer in the context of code. This is extremely valuable as there's limited resources on this, limited ideas on this, and if information does exist, a lot of it is gatekept. So let's learn how to actually proctor of OpenAI's API in the context of code. So let's go and jump in. Today, I'm going to go over two main things here. The first main thing here is we're going to go over the request body. So essentially how we manipulate the underlying OpenAI API prompt. And then the second main thing I'm going to go over today is how to use the different models, intuitively understand the different models, why using certain models more often is better than just using one specific type of model. And on top of that, just to throw it out there real quick, GPT 3.516K is one of the most powerful models, even beyond GPT-4. You'll come to understand why I made that statement a little later on in today's tutorial, but let's go ahead and start off by understanding the request body, what you need to care about in the context of code and when you're building out a SaaS that calls upon the API of OpenAI. So here we got is a couple of different, variable points such as the message, the model, frequency penalty, function calls, functions, logic bias, max tokens, and stuff of this nature. Let me tell you what is most important. Now, preface this, I'm speaking in the context of building out web applications for the context of dealing with data, manipulating data, and giving value through the manipulation of data. You may be using API and OpenAI in different contexts, such as data analysis for different outputs. I'm speaking more in the context of dealing with data and giving value by reformatting or providing additional information on that data. Just to give a real quick example of this, the Gmail SaaS example would be essentially you receive an email, we contextually look at the email, and then we give a example response based off business context with a business email already written up for that email. So this is what I'm kind of talking about here. Also in the Google API context, that business idea that I created where we're looking at a ton of different business locations, then we're taking all that large amounts of data, condensing it, finding emails, percents of whether they have website or not, stuff of this nature. So knowing that, obviously, king of all kings is the model. This is very important. Model is going to basically give you insight on how much it's going to cost to run that operation, the type of outputs you can expect based off that model, and you should be familiar, but you probably are familiar that obviously we're dealing with GPT-4 and GPT 3.5 Turbo in our modern context. So coming back over here, then we got a message. Obviously, this is probably the second most important, if not probably around the most important in the context of what do you want the output to do. So in the context of code, a lot of times you'll build out a body like this, and let me go ahead and change this to Node.js. We'll build out a body like this, and we'll provide the message. I guess I can't really increase it, but we provide a message like this, and a lot of times in your code file you provide certain variable points that are relevant and important for an output. So in the context of that email, where we create an automatic email, we'd probably provide the email data in this message so we can get a more accurate response. Now I'm going to go ahead and explain a little bit of caveats to that, a little bit of structure to that a little later on in this tutorial, but keep that in mind. So I would say model, message, max tokens, not extremely important, but it is nice to just set it, give it a little bit of idea. So typically you're dealing with outputs that maybe you only want 250 to 500. I would stray away from really large outputs like 1,000 or 2,000 as you start becoming more inaccurate. Your name of the game when it comes to OpenAI and API prompts is to ensure consistent outputs at scale. Put that on a shirt, put that on a mug, put that on your desktop of your laptop. If you want to learn anything from this entire video and take away anything from this entire video, the most important thing when it comes to being an OpenAI API engineer when prompting is consistent outputs at scale. What does that mean? That means that the quality of output that I receive from 10 different runs of that message should be the same if 1,000 people were to access that API at the exact same time. This is important as you don't want any margin of error, and there's ways to, go about it so we can ensure consistent outputs such as formatting of JavaScript, such as what I'm about to say right now, which is temperature. So I would say beyond max tokens, message, and model, which is kind of just like most of the cake, right? The most important thing for you to understand is going to be temperature. Now, in the context that maybe you're dealing with outputs that you really want to be creative, this may not apply. But what temperature does, as you see here, we have a value between 0 and 2. Higher values lead to more quote unquote creative outputs. Lower values lead to quote unquote more constrained and consistent outputs. Therefore, the most important thing for you to understand is that you will need to use temperature in your output if you want to ensure at scale you have value consistently with every single output. That being said, it's not an instant guarantee. Therefore, we're going to set up a little bit of logic later on in this video showing you how to ensure that, for those one-offs, for those outliers where the AI does kind of give you maybe every 5% a crazy output, because at the end of the day, we are dealing with a AI model. This isn't consistent code outputs. We're going to show you how to circumnavigate that. But to be honest with you, if we're hiring an engineer here and I wanted to throw him a curveball and I said, okay, name me the top 5 specific inputs that I would look for in the context of building out an AI API call for a chat message. If that engineer does not include temperature in that answer, that is a no-go. That is a no-go. I mean, they might say the alternative one, which is top P, but temperature, I feel, has been better from our consistent output. So temperature is extremely important. Knowing this, let's go and jump over to the whiteboard here where you get to see my amazing art. Okay, so we're going to go ahead and draw this out real quick. So obviously we got the 3.5 model and we got the 4 model. Now, as I already kind of described, the major variable points that you need to care about as you are proctoring in code, there is going to be a little bit of more information we need to understand here. First thing I want you to understand here is obviously the cost difference is drastic. So for me to deal with 1,000 tokens for a 8K context of GPT-4, it's going to cost around 3 cents and 6 cents of output relative to a GPT 3.5 turbo model, which is 0.003 for the input and 0.004 for the output. To give you even more context or more perspective of what that means that for every 1,000 tokens that I would go ahead and use GPT-4's model for, comparative to GPT 3.5's model, essentially for me to reach 3 cents worth of usage in the context of 3.5, I'd have to do it 10. I'd have 10 different outputs comparative to just one output from GPT-4. Therefore, in theory, that means that I have 10 different shots at perfecting a way of an output when it comes to data comparative to only one shot with GPT-4, which is very important at scaling, very important to understanding your model. So knowing this, just as an overarching idea, any complex flow you build in a SaaS, any complex you build in a GPT output, even though you got to bite the bullet a little, every single one of your logic flows should end on a GPT-4 model. I don't care what you say. This is important. Even if 90% of your outputs are perfected with a 3.5 model, you're still going to end it with a 4 model. Why do I say that? Because the 4 model is going to be your first check, your first insurance check on making sure that if you have 10,000 users, that 100 of those users don't get some wonky output, because GPT-4 acts as that first cover, that first barrier of, craziness. That's the first thing you need to understand. The next thing you need to understand is based off that comparative analysis we just did there, where there is a 10x difference between, basically I could run this 10 times until I reach the cost of this. That's really good. That's extremely good. Because what that means for us is that means that essentially if we get 90% of consistent outputs and we're doing it at 10 times less of the cost compared to if we would have used a GPT-4 model. Knowing this, let's go ahead and talk about some other insurance brackets we can add in order to ensure consistent outputs at scale. So most of the times you're going to start every single logic with some type of GPT 3.5. I would encourage you to start at 16K. Yes, you're biting the bullet a little bit more on cost, but at the end of the day, if you get front loaded with more data than expected or the outputs more than expected, you're giving yourself insurance. You don't get timeouts. I mean, this is very important stuff here. Yes, there is basically 100% difference in cost between 4K and 16K, but we're talking about consistency and we're talking about scale. We're talking about if you have 10,000 users. We're not talking about if you have 50. and now I'm going to use the 4K model. Maybe like one person has an issue. Let's try to make it so this is automatic and I don't even have to touch it in the future. So we're going to start a 16K model. We're going to use the 16K model like it's, I don't know, just like I don't know, like I'm shooting a paintball gun and I don't really care about every single little paintball, right? That's how we're going to use a GBT 3.5 16K model, because it's going to be used as rapid fire or a way of compressing data. And we can kind of be a little bit liberal with it in the sense of we can use it as much as we want because we know it's very cost effective. We're getting 10x relative to the GPT-4 model. Knowing this, when you are building out flows and you're building out logic, I don't want you to go with the mindset that I need to use as limited amount of message prompts as possible. No. Flip it on its head. I want you to use that 16K. And if your MVP gets to the point where essentially it works and you had to use the model 10 times, 16K 10 times, and then you had to use GPT-4 once, that's still really good, because now that 10 times is ensuring that whatever you're doing, you're providing value at 1000x. So knowing this, 16K is great for compressing data. What is another way that we can ensure scaling ability when it comes to using AI prompts? As end of the day, this isn't just JavaScript looking at data and being very specific. The way we can ensure, making our data look as amazing as possible before we feed it into the GPT-4 model. And obviously, keep in mind, the data we're providing to that GPT-4 model, we want to make sure that it is as specific as possible, as limited dictation as possible, the most limited amount of data you can provide the GPT-4 model for a exceptional value point. I don't want to have 1,000 words of data provided into that GPT-4 model when only really the GPT-4 needs around 400 words. So in that context, we would use GPT-16K to compress the data for the specific points we need in that context. Now, there is another layer of protection, another layer of insurance we add in these flows and this logic, and that is going to be our good old friend JavaScript. Here's what JavaScript does for us. So let's go ahead and jump over to an example, and we'll do that email example again, as we have discussed this SaaS in great detail up to this point. So we're going to go ahead and start with our email here, and we'll say the end conversion point is going to be a email response. So how do we go from email, blue email to red email? And how do we do it well? The way we do it is this. First, we're going to receive the data from this email and obviously a Gmail API call. Great, we got all the data associated with that email. Subject line, body, signature, metadata, anything associated with the email, attachments, everything associated with the email will come in that API call. Okay, so what do we do next with this API? What do we do with this data? Do we jump it right into a 16K block? Do we jump into GPT-4? No. Take a step back. First, we filter. And what do I mean by filter? We remove stuff that genuinely has no impact on our output, that actually just makes the entire process more expensive. So to give an example in the context of an email, is before we would input it into our first GPT 16K block, we would use JavaScript to remove the signature found in the email if it's not found prevalent or relevant in our context. That signature block, okay, remove that data. Now the entire operation is cheaper. We removed extraneous data. Maybe in the context of responding to an email, we don't necessarily need the subject line. Okay, remove the subject line. So now, using JavaScript, which has no AI prompt cost, and basically instantaneous, we are getting access to what we care about in this context, which is the body. So now that we got the body post JavaScript, this is when we would input it into a GBT block and do our first form of compression or data manipulation. So in this context, with the GPT-16K block, maybe the relevant data that we provide in that first block is we essentially identify this as a message body or an email body, and then we identify that we are this business with this context because the users already inputted that into their backend or onto your front end of your underlying website, and kind of proceed from there. Or maybe our first block is a sentiment analysis block. So in that context, maybe we could go for 4K block And the sentiment analysis block's purpose is to get the context of that email, identify it into separate categories that you've identified in your platform, and proceed from there. The point being, though, is this. Throughout this process, though, we're going to run into issues with these AI prompts, even when we have low temperature, we perfected the message prompt, and we're using the correct model. What does that mean? That means we're going to do this. So let's just assume that let's just do like a very simple flow here. Typically, you're going to get a little bit more complex. But let's say we start with 16K. 16K just compresses the data, maybe throws a tag on it, and then gives it to the for block to basically batters up. Let's hit a home run for the for block to give us the perfect output of the response. But sometimes what we noticed is that within 90% of the outputs, we are good to go. It sends out perfectly and no hiccups. But we notice in 10% of the in the outputs, we get extraneous data that messes up the for output. What I mean by that is, let's say sometimes 16K throws in, this is the description, or this is the response. And then it gives the perfect response that we're looking for, right? It gives the response of the body email, but it says, this is the response. You know, AI does that sometimes when you're talking to ChatGPT, where it's like, most of the time, even automation softwares, you're like, okay, this is good, this is good, this is good. And then sometimes they'll just randomly say, hey, this is the response. This kind of stuff is not acceptable in the context of scale. So what we do in that context is that we would use JavaScript to remove certain outputs that include that. So you have one or two options here. So the options that are more clear cut and obvious to us as just looking at it visually, we can use script in order just to remove it. But there is going to be some outputs that are so bad, or honestly, some outputs that actually come out as empty strings, didn't receive the data right, an error occurred, a timeout occurred. For all logic, including timeouts, errors occurring, strings are empty, you're going to set up an else statement where if that doesn't look perfect, we're going to set up an else statement to reset this entire flow and send it back to the beginning. We're going to send it back to the beginning where we take the signature again, the subject again, then we throw it to the 16K, then we throw it to the for, and we're going to have that else as insurance. Now you might be saying to yourself, isn't that cost inducive? Like, weapon if if I'm resetting it again, I have to keep calling these functions again. Well, let me put you into a little bit of perspective. First thing you need to understand is that we're adding this else not as like every 50% of the time we have to incur the else statement because the output is so bad. No. This else statement really only occurs 5% of the time, assuming that our temperature is right, our message is right, everything's right about the initial AI API prompt. This is a 5% insurance bracket. So at scale, we don't get that 5% of customers that had this issue sending you an email talking about, hey, I used your service, the output was bad, and you get a bad review, or they stop using your service, subscription rates go down, et cetera, et cetera. So that else statement is not the 50-50, it's more of an assurance bracket. It's just giving you insurance because end of the day, you could have the perfect prompt in OpenAI API, you could use the perfect temperature, you could have the perfect data points, but sometimes AI is just going to be AI. And it's going to give you some wonky output that's going to throw off the entire flow. And then you're going to get an output of an email talking about something that's completely different than what the original intention was 5% of the time. This is unavoidable. At least now it is. So knowing that, we now have broken it down how to do OpenAI prompts in the context of code. What do you need to take from this? First thing you need to take from this is that know when to use the right model, know when to use the right, obviously prompting, temperature is important, max tokens is important. OpenAI API, use JavaScript, remodel, restructure, format your data, incoming data. The less data you have in an AI flow, the better the flow will incur. Therefore, yes, moving that extra sentence that you might think is just it, like for example, the subject line of the email, it's not that big of a deal. I'm gonna keep it in there. If it doesn't help the end conversion event, remove it. It's not needed. That's the name of the game when it comes to OpenAI's API for cost and for scaling. The name of the game is to ensure consistent outputs. And in today's video, I went ahead and described that for you. And in later videos, I plan on doing more complex, in-depth tutorials on this, especially on the error functionality part. So having insurance in a bunch of different realms when it comes to your software is very important. You always want to weigh out. You never want a dead end where something breaks and then, there is no else statement giving it a way out. That's very important in the context of software. At the end of the day, when you build software, we're not treating this like it needs my attentive attention all the time. We're treating this like I built out a solution. It does a very specific task and it does it every single time with no flaw. So if you like this kind of talk, check out the playlist at the end here. It's called Corbin AI Talks about business and more specifically about SaaS, as this is a new industry arising here. If you want more in-depth tutorials on actual applicable skills, you can check out our automation tutorials or our ChatGPT tutorials. I'd say beyond everything I just described there, the most important skill to learn, no matter the context, no matter the background, is knowing how to talk to ChatGPT. If you've only talked to ChatGPT for 2 weeks and you say it doesn't work, trust me, it works. You just spend the time to learn how to use it. It's going to be the most powerful tool to use in the next 10 years. You can truly do anything with it. And when I mean anything in the context of building a software, anything for your business. It is an extremely powerful tool. But without further ado, I'll see you in the next video.
Thanks for tuning in. And yes, surprise, I'm an AI avatar. Make sure to explore more here at Corbin AI, where we demystify AI for your personal and business life. Until next time.